Hey guys, in this video we'll be implementing and doing the layout for a simple class structure in Lua. The class structure will be written in Pure Lua and it will be portable to all Lua environments running version 5.2. This is going to be running in the Love2D framework, which runs on Windows, Mac, and I believe now they are doing some mobile development as well. This structure is going to be very basic, but it'll be sufficient for the projects I have planned out, and if there's any missing features, I'll either add them in later or do another video going over some of those changes and implementing them as I find that I need them. If you're interested, the source code will be linked in the description down below. This is going to be my first video in a series of coding challenges that I'll be doing, so with that, let's get started. First of all, I have this main.lua file set up and this empty class.lua file. The main file just has some basic functions that I need to do stuff on when the project loads, and when it draws. This we're likely not going to be using, but this is the update function, which does updates over cycles. So with that, let's begin. And let's go. So to start out, I'm going to need a base class table to hold all of the info. And I'm going to need an index for all the classes that we make. I need 3 functions. I need a new class function. I need a constructor function. Oops, I almost typed constructor. And I need a new method function to make new methods. Alright, so to get started, let's look at this new class function. First of all, actually, we need a way to determine whether or not a class exists before we start I'm thinking ahead. Before we start making the classes, we need to return the type of class. Class's index name. Just to see if we have a class. So if we do not have a class already, we should give this arguments, huh? So we know that this needs it needs a name of the class, and it needs an array of member names. So we're going to get args in. So if the class doesn't exist, of the name, then what we're going to do is create a table. I'm going to set a meta table for this to class. And then we need to store the args variables that we got passed in. And then we need to add the index to our list. And then if the class already does exist, we need to assert out and say that class name is already defined. So that just lets us know if the class doesn't exist, we create a table, set its meta table to the class table, which is up here. We store the arguments, store it in the index. And if it does exist already, throw an error. We already defined that class. For the new function, we're going to do something similar. I need to pass in the name of the class that we want to construct an object from. And I need an array of the member argument values. Actually, I want to say values so I don't clutter up that concept. So we're going to check the opposite this time. We're going to check if the class exists with the name, and if it does, then what we're going to do is we'll say make a table. We're going to do set its meta table to a new table with the index being class indexed name. Okay. And oh, if we want to know what the class is, here, let's do this. If we want to know what the class is, we need a two-string function that returns name. So this is going to make it so that if there is something that we call on the class, an object that we pass, that doesn't exist in the table we passed it, but it exists in this table, it'll look in this table for it, and then this just prints out the name of the class when we convert it to a string. Okay. So then we need to do, for every integer pair, for every integer pair in the class's args table, we need to set v. So v is the name of the member. We're going to set that to the argument's index k value that got passed in. And then we're going to check for later. This is going to be a piece for later. We're going to check if the table, or if the class has an initialization function. Then what we do is we'll call it so that the user does not have to call the function. And then we return the new object to the user. And then down here, we have to get we'll say else, so the class doesn't exist. What we'll do is we'll assert false and say class of name is not defined. That means that. Then we'll go back to we'll go down to our new method. This is going to take in the name of the class, the name of the function, and the actual function. So we'll say class name, function name, and the actual function. And we'll say, oh, we need a new local. We need to have a local function that says method exists, function name, and function. And we're going to return type class, classes, name, function, equal to function type. So that just lets us know if we already have a class, or a method, I'm sorry, if we have a method that's already called. So first, in this function, we're going to say, does this class name exist? If so, then we check if the method name for class function, hold on, I don't like this. It's just bothering me to say like method and function. They're kind of weird. It's kind of weird for me. So we check if the method exists. So we don't want to overload or overwrite a method. So if it doesn't exist, what we do is we say classes, class name, method name equals method. So we store it. And then we have to do some debugging here. So we'll say else assert false method name for class name already defined. And then for here, we'll say This is when the class doesn't exist, so we'll do another assert and say class name, oops, not defined. Oh, and I missed a period here. It's not going to hurt anything, but it'll bother me. Alright, so let's test this real quick. Let's make a new class of the name test with the members, let's say name and value. And let's make a local function which takes in self and some value. And it does, let's make a local string and say for kv pairs in all key pairs for self, do if type v is equal to string or type v is equal to number. Then what we'll do is say out gets concatenated, or v gets concatenated to out end. And then we're going to return the value of out dot concatenate colon some value. I'll end that function. And we'll say class dot new method test. And then we have to pass in function. And let's just make a new one. So we'll say test equals class dot new test. Pass in hello world and 1, 2, 3, 4, 5 as our values. And let's just go to draw and say test.name, print that at 0, 0. Test.value, print that at 0, 20. And let's call our function and print that value out. So I'm going to use the member, the colon, which is for member. Oh, we didn't pass in a name for this function. What should we name this? Get all data. Oops. Get all data. So we'll say get all that data. And we'll pass in an extra value, let's say 25. And we'll print that at 0, 40. So let's see if we have any errors in the code. End expected to close line on class. I missed an end somewhere. Where did I miss an end? 46, line 46. Oops, I missed it right here. Okay. Class test is not defined on line 39. Why is class test not defined? What's the call stack for that? In function new. New class, test. New method, test, test. Okay. So let's go to the new class. If not class exists, name. Local t set metatable t index equals class. Args class classes name equals t. Well, one way we can test this is I just duplicate this line and see if I get the class is already defined function. Okay, so the class is already defined. But here I say it's not defined. And that is on line 39. Oh, a typo. Hello world 1, 2, 3, 4, 5 colon 2, 5. Check our data. That looks like it works. All right. So about 13 minutes and 22 seconds. That's not bad for that. There's a couple of things missing that I can think of off the top of my head. This is something I didn't show you guys, but this is what happens when I do toString for this. It's one of the reasons I set that function in the constructor. So if I set that to toString test, what happens is it will print out test. It will print out the name of the class, which is helpful when you're working in a bigger library. It looks like everything works though, which is good. There are a couple of things I want to either do later or put in another video, like extending the class library or whatever. I'm gonna put them at the top, off the top of my head. It's oh, there's no way to do default values, so you can't do default values or optional arguments with this library. There's no way to have multiple constructors. That's pretty helpful if you want like a default constructor or non constructor with certain arguments and whatnot. So I have to look into a way to do that with maybe meta tables or do a lookup table. And then another thing is the way I access the members here is something that I don't really want to do. This is very open and dangerous means of modifying data. So maybe we can set a Boolean value to say that members make the members private. And I might do another video kind of going further on those concepts and extending this class library. Like I said, it's very simple, not much to it, pretty easy implementation. You define the class, you define its arguments, you can make functions, add the methods, you can instantiate it, maybe have like a make like a destructor function, maybe deallocate the memory, delete classes, maybe you want to delete the method or methods. So there's a couple of things here that can easily get thrown into this library that I just not going to cover in this video. But that's it. If you guys want to see more of these coding challenges and see more of what I'm going to be working on as I develop some of these kind of boilerplate pieces that would fit well into other projects, make sure you subscribe, keep up with the channel. I'm going to be posting a couple of videos a week, and I appreciate you watching.